everyone. In this lecture video, we are going to discuss a design thinking based approach to ANOVA. ANOVA is nothing but analysis of variance. So here in DT we have 5 stages. Each stage will be explained by one step. So let us start with Nitin.
So as an AML and AML learning student, we often build multiple models like decision tree, support vectors, machines and neural networks to solve the same problem. After training these models, we evaluate this using metrics like accuracy, precision and recall. But many times the accuracy scores are models are very close to each other. So we can't choose which is better one. For example, one model might have 91% and another model might have 98% and another model will have 89%. At the first glance, they all look almost the same. So we start to feel confused like which model is most efficient in accuracy. So this small difference in accuracy meaningful or this happens due to the random variations in the data. Without proper analysis, we may choose a wrong model which may affect the performance in the real world application.
So after understanding the empathy part, we need to let's define this problem clearly. So mainly in this problem, we are statistically verifying whether the models that we use and or the features that we use are properly good or is there anything bad or something. So by defining the features or models which they are significant or not, it is an important thing. And by calculating or analyzing the observed features or model, we check if the features were correct or the model were correct.
So we are going to say that every decision should be made on evidence, not on the assumption, right?
Yes. And if a feature will be wrong, it could lead us to a wrong output for
So
the
like
model.
errors.
Yes. So if features will be more important.
Is the whole going to explain ID now?
I tell about idea. We thought of running experiment randomly, testing one factor at the time. But these methods are inefficient and maybe introduction based. So we explore the structure statically approach.
So now I will be explaining the prototype model. So in ANOVA, we use it to compare the mean of 3 or more groups. So for example, model A, which is 85%, model B 87%, and model C 86%. So to check the ANOVA, we compare the variance within each model and also the variance within the model's accuracy.
So there are 3 types of ANOVA also. So first one is one way, in which we will be discussing about the model feature along with the errors. So in 2 way, it will be discussed with inside the variance as well as the comparison part. So when it comes to 3 way, we call it as Latin square. So now who is going to explain the testing factors?
After conducting the experiment, we analyze the results of using ANOVA. We check whether algorithm performance differences statistically significant or not.
So how will we fix the null hypothesis and Armstrong hypothesis?
So based on the given problem, we can decide the null hypothesis.
Like there is no significant difference between the factors and the errors. Like that we will fix the null hypothesis. So at what stage you will accept or reject null hypothesis?
When z alpha value is greater, then you select x naught value, accept x naught value be accepted.
When the critical value or z alpha is greatest. Okay. So shall we discuss the applications of ANOVA?
Comparing algorithms across data sets, testing models in different environments and reducing experimental bias.
So applications are improve the reliability itself. It will give a truly a simple method to which is solution will be more better instead of getting a random.
Design thinking help as the identify the problem clearly.
So, using the design thinking framework, we understand the problem clearly and we are into a solution much easier way.
And ANOVA gives us a powerful solution to